Hello everyone, welcome you all at Lokesh Sir Unlimited Studio. So we starting here chapter number 11 with the name dual nature and radiation of matter. So student, in the last chapter at the start of wave optics, what we have discussed the all the historical incidences for the explanation of different type of radiation. Radiation. Okay. Time to time, different scientists given their theory. In order of that, first there is produce Newton's corpuscular theory. Clear? Newton's corpuscular theory is said that like the light is made up of the tiny particle. Okay, and those particle are corpuscles. And Newton has given the practical evidences of like reflection and refraction by using the Newton corpuscles theory. After then, Huygens produced his wavelet model. Then Huygens, okay, and he said that the light is a form of wave. He supported the light as a form of wave. So he established the wave theory of light. After then, by the great experiment of Young's, it is completely established that light is light is obtained. The signals, the radiation is coming to the earth in the form of a wave. Okay. So after Young's experiment, Young's double slit experiment of interference and diffraction, wave theory is completely established. Okay, but still there are two phenomenons are like a question mark in the field of wave optics. Those are photoelectric effect, photoelectric effect, and Compton effect. Okay, Compton effect. Also, mm, pair production, pair production. Only this one is in your syllabus, but all these three and one more is there. Inhalation, inhalation. Okay. So such like event cannot be explained using wave theory. Wave theory. But yes, but they are obtained by the radiation. Okay, these phenomena can be carried out by using the radiation, but these phenomena cannot be explained by the wave theory. So there is a question: is still any another form of radiation exists or not? Okay, so you will get your answer of these question in this chapter. So the name of the chapter is dual nature. Okay, so at the end of before the end of the chapter, you well aware of this fact that light having dual nature. Finally, the theory of light, or you can say radiation. When I am talking about light, it is complete family of light that is called radiation. Okay, so radiation finally established as a dual nature, it having the dual nature both as particle as well as wave. Okay, particle as well as wave. Some of the phenomena can be established only particle, like photoelectric. Some of the phenomena can only be established, can be only be shown by the nature of by the wave nature of radiation. And some of the phenomena like reflection and refraction presented by the both type of radiations, particle as well as wave. Clear? So in this chapter, we have to face the situation for the dual nature of radiation. Okay, radiation means energy and matter Okay, so we will check first. Now we are confused about the nature of radiation. Okay, nature of radiation. Does the nature radiation having is two aspects? After then we will know if radiation act as a particle, then matter can also act as a radiation or a wave. Clear? Yes, if a light wave having its particle nature, if a light wave having its particle nature, then any particle can have also a wave nature. Clear or not clear? So there is, you can say, some type of interrelation between radiation and matter. Means matter is a radiation and radiation is a matter. There is equilibrium between the two nature. of the radiation. Clear? So, starting with the introduction, the discovery of phenomena like interference, diffraction, and polarization of light established the light is a wave nature. Yes, we from the previous chapter we have seen that the discovery of phenomena like interference, diffraction, okay, these experiment interference and diffraction and polarization. Okay, so it was not in our syllabus, but still you must know that these experiment establish the light, or you can say radiation. Okay, what is light? Light is a radiation. Radiation is of wave nature. Okay, they establish that these all the radiation having wave nature. The Maxwell equation of electromagnetism and Hertz experiment on the production and detection of electromagnetic wave in 1886 strongly supported the concept of wave nature of light, exactly because the discovery of Maxwell's equation uh, is according with the wave nature of light. Clear? Wave nature of radiation. In 20th century, the discoveries of photoelectric effect. Yes, this whole work is of uh, is of 18th to 19th century. This whole work of during the you can say Young's and in the time of Newton's corpuscles. See, during the 16th century, there is Newton, and in the same century, there is Huygens, Christian Huygens. Okay, at mid 18th century, there is who Thomas Young. Okay, so all these discoveries related to the uh, wave optics or wave nature of radiation has been done till 1886. Okay, till the start of 19th century. Clear? Still 19th century, this all happened related to the wave nature. But in 20th century, okay, in the 20th century, the discovery means after the year 1900, completion of 19th century, in the 20th century, the discovery of photoelectric effect by Hertz. Okay, what Hertz discovered? Hertz discovered the photoelectric effect. Compton effect by Compton were explained by quantum theory of light. Yes, I told you that mainly two phenomenons, photoelectric effect and Compton effect. Clear? So these two discoveries cannot be sufficiently explained by the wave theory. Rather, they are explained by the quantum theory, or you can say the particle. What does it mean? Quantum? Quantum means particle theory of light or radiation. Okay. So according to which light consists of the packet of energy, means light is made up of the particle. What particle? Energy particle. Okay. So Max Planck given this suggestion. Okay. He said that light is made up of the very a small energy particle, and these particles are called photons. These particles are called photons. Clear? These particles are photons, according to which the light consists of the packet of energy which is travel in a straight line, and these particles travel in a straight line. Okay, with the speed of light. Each packet of energy is called photon, and this photon, each particle having energy E equals to h nu. Okay, so this is the energy of photon. Must write this is the energy of photon. One photon. So energy of one photon equals to E into h nu. Clear? Thus, the particle nature of light was established. So, in this way, Planck has established the particle nature of light. Clear? Hmm. So, what is important here? The first thing, a light radiation, when a light radiation coming, so this light radiation is made up of the stream of photon. Okay, each photon is a energy particle, and each photon having an energy, it's a particle, energy particle having energy E equals to h nu. Clear or not clear? So a photon having its own characteristics frequency. According to the frequency, its energy may be greater, or you can say less or more. Okay, because clearly here E is proportional to nu. If the frequency of the photon will be high, then its energy will be more. Otherwise, its frequency is less, then its energy will be also less. Clear or not clear? H is here Planck constant. Clear or not clear? Okay, so this is the suggestion by Planck that light is made up of the a very small particle of energy. These small particle of energy are called photons. Clear? These particles are also called quantum because particle means quantums. That's why it is called quantum nature of light. Clear? Okay, so equals to h nu is the energy of the photon. Yes. So these photons are moving with the speed of light. Remember, these photons are moving with the speed of light that is equal to 3 into 10 to the power 8 meter per second. Each packet of energy is called photon with energy h nu. Thus, particle nature of light was established. Okay, after the establishing of the particle nature, let us moving towards experiment performed by the Planck and theory given by the Planck, that is photoelectric effect. Photoelectric effect. Clear? So before come to the area of photoelectric effect, you must know some chemistry concept. First, it is free electrons. What are free electrons? First I want to give here example of sodium. In a sodium structure like this, sodium having 11 electrons, two inside. First, it is nucleus. There are 11 protons, plus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Clear? 11 protons are there. Around surrounding that, first there is two electrons. Then after how much? 8. 1, 2, 3, 4, 5, 6, 7, 8. Clear? So 8 plus 2 become 10. Next, in the third cell, there is one electron. Okay. This electron is attached with the nucleus with very less amount of electrostatic attraction force because the cell is outward, and F is inversely proportional to R square. If distance is increases, then the amount of the force will be decreases due to the electrostatic force of repulsion. Electrostatic force, Coulomb's force. Clear? Attraction force is there, but it is having very less amount of force. Clear or no? Okay, to obtain its stability, this electron try to lose its orbit, okay, or try to fetch out, eject from its orbit, okay, but it has to it requires some energy that enable it to break this bond, okay, because there is a attraction between the protons and electron, okay. To remove this attraction, this electron requires some amount of energy. Yes or no? Yes, like you are inside at your home, okay, and you are just at the periphery of your at home. If some of your friends want to take you outside from your home, he had to gives you some bribe, like, hello dear, take this chocolate, okay, then surely you will get out of your home. Yes or no? So this electron also requires some very few amount of energy, okay, and this is called free electron. Clear or not? Free electron. Till the time it is not supplied this energy, it is a part of this atom, this lattice, its lattice. Clear or not? But once it gets sufficient energy and it is fetched out, then it is called free electron. Okay. Yes. So what is free electron? Let us see the theory of free electron. In metals, the electrons in the outer shells are called valence electron. Yes. During chemistry, in the chemistry you seen, these electrons are called, the outermost electron is called valence electron. Okay. And from the valence electron, the definition valency came out that the number of electron donated by a electropositive atom is called its valency. Okay. And the number of electron accepted by electronegative element is called its valency. So these are called valence electron of the atom, and these are loosely bound. Everyone knows that these are the loosely bound electrons. They are free to move easily within the metal surface but cannot leave the metal surface. Such loosely bound electrons are called free electrons. Yes, they are free to move easily within the metal surface but cannot leave the metal surface. So, these electrons, okay, these are loosely bounded electrons. These electrons are free to move easily within the metal surface. Okay, they can move in the metal surface, but they cannot leave the metal surface. Yes, they cannot come outside of the metal. Clear? Because they don't have the energy to lose to or to leave its lattice. Okay, its orbit. Clear? Okay, but they cannot lose their surface. They cannot leave their metal surface. Such loosely bound electrons are called free electrons. So these electrons are called free electrons. Clear or not? Like in a magnesium, only outermost orbit two electrons are there. That's why magnesium make its positive 2 ion. So these electrons are supposed to be free electrons. Clear? The free electron are held inside the metal by attractive force of the surface called restraining force. Yes, so these electrons are held inside the metal by attracting force of the surface is called restraining forces. Now, till now, the electrons are moving inside the lattice. They are revolving here and there, okay, and they are residing on the metal surface. Clear or not clear? Like if I talking about magnesium, if I talking about sodium, see this is the sample of sodium. Consider a typical example of sodium here. So this is the outermost electron, okay, and to leave this its orbit, this electron needs a bribe, you can say bribe or energy of 10 electron volt, okay. So the requirement of this electron to break out this attraction with protons, okay, inside the nucleus is equals to 10 electron volt. This electron volt that you give me 10 electron volt energy, I will leave my orbit. Clear? Okay, so this is the metal surface, sodium metal surface, and here this is the green one electron. This is the atomic view, and here is it is the crystal view. Clear? So can you correlate this? This is the same electron here. Okay. Now, when you have given a energy of sunlight, energy of sunlight is equals to 5 electron volt. Clear or not clear? So as this signal, as this radiation of 5 electron volt impacted on this electron and said, "Hello, my dear friend, you want to come out?" Yes, he said, "Yes, I want to come out. So give me 10 electron volt energy. I am sorry, this radiation, I am carrying only 5 electron volt energy." He says no. Okay. 5 electron volt energy is not sufficient to fetch it out from its orbit. Okay. So it's became as a free electron, but not getting out of the surface. Clear or not clear? But once you have sent the radiation of 13 electron volt again, yes. So this is the next radiation of 13 electron volt. So you have increased the energy by increasing the frequency. Clear or not clear? Once you increase the frequency of the photon, your energy of the photon also increased. So you have increased the frequency of the photon. So energy of the radiation becomes increased. Suppose it is 13 electron volt. Now, when a 13 electron volt signal impacted on this photon, he said, "My requirement is only 10 electron volt. So by using just 10 electron volt, it just leave its orbit and getting out of the surface." Clear or not clear? Yes. So the metallic, you can say what type of bond is there? Yes, restraining forces. Okay. So the electron will free from the restraining forces and getting out of the surface by this taking this energy of 10 electron volt. Clear or not clear? But after then 10 electron volt, as the total energy of the photon is given by 13 electron volt, so 10 electron volt energy expenses to get it out from the surface. Remaining 3 electron volt, what will happen? Remaining 3 electron volt, it will move freely out of the surface. Okay, it will move freely out of the surface. Clear or not clear? Yes. So this energy, minimum amount of energy that is required to fetch out of the electron from its surface is called work function. What it is called? Work function. Yes. So if you have given 13 electron volt energy, then it is, you can distribute it in the form of 10 plus 3 electron volt. So first, this one requirement just to leave the surface. Yes, getting at the your just out of door. Okay, like your there is a door in your home. So just you touching the roadside. This energy that requires to make you out of your door is called work function. So this is called phi naught. Clear or not? So this is equals to phi naught. Okay. As energy is made up of the E equals to H and nu, so surely phi naught is also the product of H into nu. So corresponding to the work function, there should be a minimum amount of frequency. Minimum amount of frequency, yes or no? Minimum amount of frequency is required to make this work function. This minimum amount of frequency is called threshold frequency. Okay, threshold frequency. Clear or not? Okay. So, like, so this is called threshold frequency. And then this 3 electron volt is what? This is kinetic energy. This energy, remaining energy is equals to kinetic energy. Clear or not? Remember, if you have given a radiation of 10 electron volt, then what will happen? If you are given a radiation of 10 electron volt to this electron, then electron will only come outside the surface. Okay, and it will having its kinetic energy zero, so it will be reside there, okay, at rest, but it will come out of the surface, like you are just waiting for your school bus, just getting out of your door, okay, and waiting. Clear or not? Yes. So students, now we have to read work function. So what is work function? Formula for work function equals to phi naught, and phi naught is also energy, so it is in the form of h nu naught. Here nu naught is called threshold frequency. Okay, so write this formula, very important. Phi naught, this is called work function. Okay, phi naught is called work function equals to h nu naught. So what is work function? Yes, any problem? H is Planck constant, students. H is Planck constant. Okay, energy is made up by the product of Planck constant multiplied by frequency. So work function of a metal, yes, it is different for a different metal. Like some metal having very less work function, like cesium. Cesium is a metal. You check in the first group, lithium, sodium, potassium, rubidium, cesium. Yes or no? You know, by going down to the group, atomic size increases. On increasing atomic size, the attraction from the outer side electron decreases. Yes or no? So cesium having the minimum attraction of electron from its nucleus. So it is very radially to get outside of the its atom. Yes or no? So for cesium, the electron need a very less amount of energy compared to lithium will require a highest amount of energy. Yes or no? Because lithium having a small size and having great attraction force because it is very closer to the proton nucleus. Yes or no? So maybe if for a cesium, you have to give the 3 electron volt energy and your electron fetched out. Okay. And here you have given 10 electron volt energy and there is no fetching of electron. Understood? So it is depend on the metal to metal. It is the property of metal. Clear or not clear? And yes, this whole chapter, photoelectric effect is only based on metal because metal can only provide electron. Okay. Non-metal. You cannot take any advantage of electron from carbon as carbon is non-metal. Clear or not clear? So you have a carbon layer, you have a carbon surface, carbon strip or carbon bar is there, and you try to fetch out the electron from this carbon sample, then it is impossible to get a electron. Clear? Because carbon is a non-metal. Clear? Okay, students. So work function of a metal. Yes, work function of a metal. So it is the property of metal is the minimum energy required by an electron to just escape from the metallic surface so as to overcome the restraining force at the surface. Yes. Why that energy is needed? It is just needed to overcome the restraining force. Okay. To break the bond of restraining force at the surface. Clear or not clear? Yes. Work function is represented by phi naught and it is measured in electron volt. Okay. It is measured in phi electron volt and it is represented by phi naught. So right there. Phi naught equals to H nu naught. Important formula. Clear? Phi naught equals to H nu naught. Yes, so time to time formula will come. So first we have seen the two formulas. First, energy of the photon E equals to H nu. Clear? Yes, E equals to H nu. Energy of the incidented photon at any surface E equals to H nu. This is the energy of the photon. Photon required energy required by the electron to get out of the surface, just to get out of the surface. That is called work function. Work function equals to H nu naught. Clear? It is depend metal to metal. Okay. Hmm. So work function is represented by phi naught, and phi naught equals to H nu naught. So write the formula phi naught equals to H nu naught. Clear? And energy of the signal, energy of the photon is directly proportional to frequency. Greater will be the frequency, greater will be the energy of the radiation. Clear? Now, electron emission, third part, electron emission. Now, check how electron emitted. The phenomenon of emission of electron from the surface of a metal is called electron emission. The electron emission from a metal surface is possible if the energy possessed by electrons is more than work function of the metal. Yes, when your electron will come out, when your energy supplied is either equal to work function or greater to work function. Clear or not? When your energy supplied by the radiation is greater than work function, then electron get out of the surface, and also it will having some kinetic energy. Understood or not? Yes. See, the energy, you see, here it is a work function, like the work function equals to 10 electron volt, and you have provided the radiation, you have provided of radiation of 10 electron volt. Clear? Then what will happen? This electron just get out of the surface. Clear or not clear? Now see the second case, your work function phi naught, requirement of minimum energy for to fetching out, is equals to 10 electron volt, and you have emitted your signal of 9 electron volt. Yes. Thus electron fetched out of the surface. The need of energy equals to 10 electron volt. This is work function. And in signal, a radiation of 9 electron volt incidented on this electron. Does there is emission of electron? No, because 10 is needed and you have given 1 and 9 electron volt. So 1 electron volt is less. So there will be no emission. Clear or not? There will be no emission. Okay, got it? Hmm. So see, the electron emission is from a metal surface is possible if the energy possessed by the electron is more than, or you can say, or equal to the work function of the metal. Clear or not clear? The required energy of the electron emission from the metal surface can be supplied by free electron by one of the following physical process. Now, in which way you can give this energy? Here you have seen you have to give the energy to this free electron. Yes or no? To fetch it out from the surface, you have to give the this electron energy, which is greater than or equal to work function. Clear or not clear? So three cases are there. First, your energy supplied. Tell me, but see very sincerely and answer me. Where your energy supplied is less than work function. Yes. Does there is any electronic emission? Yes or no? Energy supplied is less than work function. Does there any electronic emission? No, exactly. Second case, your energy supplied is just equal to work function. Does there any electronic emission? Yeah, exactly. It will just go out. So yes, there will be electronic emission. Third case, if E is quite higher than your work function, then does there is electronic emission? Yes, obviously electron will get out of the surface even it is dancing, okay, in very high energy, that is kinetic energy. Clear? So three cases are there. Now the situation is, in what way you can give this electron energy. Does it only one way? There is only one way, that just to incident the radiation? No, there are so many ways by uh, by that you can fetch out the electron. First is called thermonic emission. Okay, so only theory is there, no, but it is not in the much discussions is not in our syllabus. What is thermonic emission? These are the free electrons in metal slabs. Clear? And when you provide energy with the form of heat, so you have given thermal energy. Okay. Yes, in photoelectric effect, you have to give the photo energy, but here you have given thermal energy. So by taking these energy, these electrons get fetched out from the surface, and these are called thermoions. These are called thermoions. Clear? Okay. Second way, second is called secondary emission. What is secondary emission? Secondary emission, in this phenomenon, the emission of electron from the surface of metal, large number of fast moving electrons, primary electron strike on the metal surface. You see, like this is a metal surface of a cesium. You know, cesium, the electrons on the outer surface are hyperactive and quite ready to lose the surface of surface of metal. Okay. Okay, so what you have to do, you bombard these electrons by a fast moving electrons. So what happen? The bombarded electron get inside the surface. They given their kinetic energy and fetch out these surface electrons to the outside. Okay, so this is called secondary emission. This is called secondary emission. Okay, that only theory is useful. See here, this is prime electron. You bombard this one, okay, to this electron. This electron takes the energy of the bombard electron and getting out of the surface. This is called secondary electrons. Clear or not? The electrons who emitted are called secondary electron. Third is called photoelectric emission, that is in our syllabus. So this is the third way of emission of electron. It is the phenomenon of emission of electron. So what we are studying, photoelectric emission. Okay, photoelectric emission. So emission of electron with the help of photon means light. So it is the phenomenon of emission of electrons from the surface of metal when light of radiation of suitable frequency fall on it. Emphasize the word suitable frequency. Clear or not clear? Because there is a requirement of a frequency. Why? See, try to take the feel of this one. Like this electron having an energy of 30 electron volt. And energy of radiation is made up of E equals to H into nu. Okay? Yes. Consider the value of H equals to 3. That is a constant. Okay? But you have a power to alter the value of nu because nu is the frequency of photon. So you having the choice of frequencies 1 hertz, 2 hertz, 3 hertz, 4 hertz, 5, 6, 7, 8, 9, 10. You feel to make an energy of 30 electron volt, you should have the frequency equals to 10. Yes or no? Because 3 multiplied by 10 will give you a result of 30. Yes or no? So if you have a frequency of 9 hertz, then you will not get energy of 30 electron volt. Only you will have 27 electron volt. Yes or no? So and frequency plays an important role. Yes or no? So that's why you need a suitable frequency. Clear or not clear? You send a radiation, okay, but to get a energy of 30 electron volt, you having a frequency of radiation enough to make 30 electron volt. Clear or not clear? Fall on it. Here so this frequency, the minimum frequency, needful frequency, this become now 10 hertz. Yes or no? So 10 hertz. So this is called threshold frequency. It is called threshold frequency. So the minimum frequency of the radiation, okay, that will result a fetching of electron outside the surface is called threshold frequency. Clear or not clear? So three results may be there. Now help me. So if nu is lesser than nu naught, means nu naught is what? Threshold frequency. Hmm. Threshold frequency. Clear? Now, if nu is less than nu naught, now if multiplied with h, h nu is less than h nu naught. Clear ki not clear? Second, nu equals to nu naught. If you multiply with h, so h nu equals to h nu naught. Third, if nu is greater than nu naught threshold frequency, then h nu is greater than h nu naught. Clear or not clear? Now, if nu is less than nu naught, means the incident frequency having a less frequency to the threshold frequency. Yes, tell me, does there any electronic emission? Does there any photoelectric emission? If nu is less than nu naught. Yes. No, no way. See, if nu is less than nu naught, means the incident radiation frequency is lesser than required frequency nu naught, then the energy h nu becomes less than h nu naught. Clear or not? Means E is less than phi naught. You see, the energy incidented is less than the work function. Then how the electron will emit it? No. So there is no emission. Clear or not? Because energy is made up of only radiation frequency. Clear? So when your incident frequency is less than threshold frequency, then no emission will be there. Clear or not? If nu becomes equals to nu naught, means incident radiation frequency becomes to the threshold frequency, then energy by the radiation equals to required energy. Clear or not? Means energy this situation becomes phi naught. So does there electronic emission? Yes, there will be electron emission, and electron will just out of the surface. Yes, when incident radiation frequency is just equal to the threshold frequency. Clear? Nu equals to nu naught. Okay. So h nu in that case energy, if you multiply h, then h nu becomes h nu naught. Okay. What is h nu naught? It is phi naught. Clear or not? Means the energy becomes equal to work function. What is energy? And this is called work function. Clear or no? So if energy of the incident radiation equal to work function, means electron will just escaped out from the surface. Yes or no? So emission will be there. Okay. You're not understood or not? Okay. Third case, the incident radiation frequency is greater than the threshold frequency. Then what? Multiply with h. H nu greater than h nu naught means radiation frequency is greater than the work function. Clear or not? So if the radiation frequency greater than the work function, does there any electronic emission? Yes, obviously, electronic emission will takes place. Clear? Okay. So students, here the energy, what I said, is photoelectric emission. It is the phenomenon of emission of electron from the surface of a metal when a light radiation of suitable frequency. So I just talked it all because of suitable frequency. So do you understood the meaning of suitable frequency? Yes, because the need of suitable frequency is very important word here. You cannot take out your electron by all possible frequencies. Only suitable frequency. What suitable frequency? Those are greater than threshold frequency or equal to threshold frequency. Clear? In these only two situations, the emission will be there. Either they are greater than threshold frequency or equal to threshold frequency. Clear? So in these two situations, emission will be there. Here the energy Here the energy to the free electrons from their emission is being supplied by light photon. The emitted electrons are called photoelectrons. Yes. For thermal emission, the emitted electrons are called thermoions. And here the electrons are called photoelectrons. Okay. So the electron fetched out of the surface are called photoelectrons. So here the electrons that are getting out of the surface are called photoelectrons. Clear or not? Okay. So these are called photoelectron. The number of photoelectrons emitted depends on the intensity of incident light. Yes. Means one photon can emit only one photoelectron. Clear or not? One photon can emit only one electron. So number of photon increases, no, sorry, number of electron increases when you increases the number of photons. Yes or no? Number of photons means number of signals. When you increases the number of radiation, then obviously the number of photon will be increases. And if the number of photons increases, then number of electron also increases. Clear or not? Okay. Means a single photon cannot fetch out two electrons. For the fetching of two electrons, you should need two photons. For a fetching of three electrons, you should need three electrons. Clear or not? Three photons. Clear? So you have to increase these radiation, and increasing these radiation means increasing the intensity. Okay. What is intensity? Intensity means number of radiation per unit area per unit time. Number of energy radiations per unit area per unit time. Clear? So if you so number of photoelectrons emitted depend on the intensity. Yes, write this word. Number of photoelectrons emitted depends on the frequency of the incident radiation. Clear? Clear or not? Yes. So number of photons emitted depends on the intensity of incident radiations. Now next is called field emission. It is also called cold cathode emission. So this is only to just take the idea of field emission. What happening there? Like this is a your metal surface, cesium metal surface, and electron is here on the surface, that is as free electron, and you applied a strong electrostatic field here. This is plus plate and this is minus plate. Clear or not clear? You have applied a voltage of 10 to the power 8, means 10 crore volt here. You have applied a voltage of 10 to the power 8 voltage here. Clear? Now 10 to the power 8 volt. See, the charge on electron is negative. Okay. And this is a very high electric field, very high electric field. So by the attraction of this positive plate, this electron will leave its surface, okay, and getting out of the surface. So this is called field emission. This is called field emission. So this can be carried out by the application of a strong electric field. Clear? Okay. So now coming to the photoelectric effect. What we have seen the photoelectric emission. Photoelectric emission. We seen by the action of a suitable frequency photon, an electron is fetched out. This is called photoelectric emission. Now, what is photoelectric effect? The emission of electron from the surface of metal when radiation of suitable frequency fall on them. Clear? Fall on them. The emitted electrons are called photoelectrons, and the current so produced is called photoelectric current, and this whole is called photoelectric effect. Clear or not? So this is called photoelectric effect. Photoelectric effects is it is totally completely experimental setup that show you that you can flow a current with the help of photons. Okay, so that whole effect is called photoelectric effect. Actually, what happening there? Let us see. Like you have this is a typical metal surface. I'm making a metal surface here. Yes. See, this is a metallic surface. Okay, metals are usually of gray color, so I have made here a gray color metal. Every metal having its some requirement that is called its work function. So here is a typical electron, some typical electrons, first one this, second one this, third one this, fourth one this. There may be large number of free electrons are there, and all these electron having a requirement of, see this is these are electrons having a requirement of phi naught work function of work function of 15 electron volt. Clear or not? So 15 electron volt, and you have given a light on the surface, so the radiation will come to the respective electrons. So these are the called photons, and they having they are different energies. Clear? Now 15 electron volt is required. So here check this photon having a electron volt of 10 electron volt. Here it is equals to 5 electron volt. Here it is equals to 7. Here it is 19. Here it is of 20 electron volt. And here it is 5 electron volt. Clear or not clear? Now tell me which electrons will getting out of the surface. This one, 15. Yes, it will just getting out of the surface and come here. Okay. Now 20 electron volt. Yes. Yes. 19. Yes. 7. No, sorry, it is 19. It is of 19. Here 19. Clear? 7 will no photoelectron will emitted. Here 15 electron volt. Sorry, this is 5 electron volt. No. And 30 electron volt. Yes. Clear? So you see you have 4 electrons that getting out of the surface, that fetched out of the surface. Clear or not clear? Okay. Now as they just getting out of the surface, you have provided an electric field, like this is plus and this is minus. This is an electric field of positive plate and this is an electric field of negative plate. Clear or not? Actually, you have connected a plate here. Uh, Wait. A metallic plate is connected here, and outside of this, this is negative and this is positive. Clear or no? Now see, these electrons are the negatively charged particle. You know electrons are negatively charged particle. Clear? So these are the negatively charged particle. Now they are out of the surface. So this negative charge particle, um, this negative charge particle, this negative charge particle, and this negative charge particle. Clear or no? So they will be attracted toward the positive charge. Yes or no? And they are repelled by this negative polarity plate. So because negative is there and negative repel together, so they are repelled here and here they are attracted towards this positive plate. Yes or no? So the electrons are moving and like this, the electrons are moving. So the current will flow through them. Yes. Clear or not? So a current will constitute here in the outer circuit. This is called photoelectric current. Okay. So the direction of electron is downside, and you know the direction of current is opposite to the flow of electron. So in this direction, there will be a flow of current. Clear? So this is called photoelectric current. What it is called? Photoelectric current. Clear? Photoelectric current. And what is the total effect? The production of current with the help of photons, because you have emitted here photons. So the production of current takes place with the help of photons. This effect is called photoelectric effect. Clear or not? So photoelectric effect, the emission of electron from the surface of metal when radiation of suitable frequency fall on them. The emitted electrons are called photoelectrons and the current so produced is called photoelectric current. Clear or not? Yes, so this is the introduction of photoelectric effect. So from the first chapter, sorry, not 11th chapter, dual nature of radiation of matter, dual nature of radiation. Introduction we have taken the dual nature of radiation, that radiation having the two aspect, one is matter and another is wave. Clear? Radiation behave as a matter as well as wave. So we are seeing here the particle nature of the matter, because wave nature we have already seen in the last chapter. Now introduction of photoelectric effect I have given. Clear? Yes, so this is photoelectric effect is completed. Now we moving towards Hertz and Lenard's observation. So this is an experiment carried out by Hertz and Lenard's. Okay, Hertz and Lenard's experiment carried out an experiment related to the photoelectric effect, and they finally they observed so many things, and the observation are listed over here. See, so experimental study of photoelectric effect. So the apparatus, check here. This is the apparatus, okay, of photoelectric effect. A vacuum tube is there. A vacuum tube is there. This is complete vacuum tube, okay, having very much low pressure. Okay, very much low pressure. And this is a window. From that, you can incident your photons, or you can say wave, on this surface. Yes, this is your emitting cathode. Emitting cathode. It is made up of maybe sodium, cesium, or any metal. This is your emitter cathode. This is called emitter. Clear? Now, once you incidented a suitable frequency of this metal, your photoelectrons are get out, fetched out of the surface. If this is cathode, why it is cathode? Because it is connected by the negative terminal. Check here. Yes, 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 yes. It is connected by the negative terminal. Okay. On the other side, there is positive terminal of the battery that is connected by the anode. Now check these terminals. This is connected. So this is plus 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 here. Now plus goes up to here, and this becomes positive anode. Clear or not clear? Clear or not clear? Okay. Now, as the electrons emitted out of the surface, they are attracted by this positive terminal and they rush towards this positive terminal. Yes or no? And as they enter to the positive terminal, a current will be there from positive to negative, and current will flow. Okay. So this is called photoelectric current. This is called photoelectric current. Okay. So the apparatus consists of an evacuated glass, means vacuumed glass. Okay, there is absolutely very less pressure, very less pressure. Okay, means you releases all the air by using a vacuum pump. There is very less pressure. Clear or not? So evacuated glass of quartz tube. Quartz is a high quality glass which encloses a photosensitive plate. Photosensitive means photon sensitive. That is very quite ready to answer any photon. That's called photosensitive plate C. C is means cathode. Cathode is emitter of electrons, so that's why it is called emitter. And a metal plate A, that is called collector. Okay, A for anode, and anode is used here as a collector, as it is gather the electron. Clear or not? A transparent window W is sealed on the glass tube, which can be covered with a filter of a light of particular radiation. This will allow the light of particular wavelength to pass through it. Okay, so different wavelength from the sunlight source can be come to from by this window. Okay, and if there are different wavelength, they are at different frequency, because you write the formula C equals to nu lambda. C equals to nu lambda. Yes, speed of light is constant, so c equals to nu lambda. So if frequency is high, wavelength will be less, and if frequency is less, then wavelength will be high. Okay, so write the formula c equals to nu lambda. Clear? Okay, so this window will allow the light of particular wavelength to pass through. The plate A can be given a desired positive or negative potential. So here this is a plate A. First, at the start of this experiment, for understanding, I have given a positive polarity to this plate. Clear or not? I have given a positive polarity to this plate, right? Yes. So this is positive polarity, but this positive polarity can maybe changed, and it can be given to the negative polarity too. Okay. Like see here. Yes, see here. If I reversing the key, like this is the your plus plate. This is your plus plate. Clear or not? And this is your minus plate, because minus terminal is here. Clear? Now these are the terminals of the tubes, the two terminals of the tube. Can I attach this terminal here? Yes or no? And this terminal to here? Yes or no? Now you see the positive become negative and negative become positive. Yes or no? Can you do like this? Okay, so here one line is mentioned. A transparent window, this is done. Allow this also done. See, The plate A can be given a desired positive potential or negative potential. Understood. Underline. Sorry. Okay. Yes. The plate A can be given a positive potential. Usually it is given positive. But for experiment, you can also give it negative potential with respect to the plate C. With respect to the plate C. Clear? With respect to the plate C, using arrangement as shown in figure. Okay. So by using this arrangement, you can perform your experiment. Okay. Clear, beta? Yes. So this is the complete setup. Now check the working. See how this setup working. When a monochromatic means single frequency or single wavelength, because at a single time you can deal with only one frequency. Okay. So like this is a window, and from a window you have got a one monochromatic means one lambda, and one lambda refers to single frequency because C equals to nu lambda. Clear? So lambda equals to nu equals to C upon lambda. Yes or no? So for a given wavelength, you have a given amount of frequency. So when a monochromatic radiation of suitable frequency obtained from the source S means the sunlight source or any other bulb or something you can take, fall on the photosensitive plate C, the photoelectrons are emitted from C. Obviously, the photoelectron will emitted, which get accelerated towards the collector plate. Why? Because electrons are negative and collector plate A is on positive potential. Yes or no? So they will rush toward positive terminal. If it is kept on positive potential, yes. If it is kept on positive potential, they will rush. These electrons flow in outer circuit, result the photoelectric current. Yes, I have shown you in this experiment, like these electrons are flowing in this outer circuit and they will make a electric current. Correct? Due to it, microemitter shows a deflection. So where is microemitter? Here it is microemitter. Okay. If there is a needle, just you enter your amount of light, the needle will be deflected and there is a slight amount of current. Okay, clear? Means there is a current flowing in the circuit. Mm. Yes. So outer circuit photoelectric current. Due to it, a microammeter shows a deflection. The reading of microammeter measure the photoelectric current. Yes, the reading of this microammeter will measure the photoelectric current. Got it? This experimental arrangement can be used to study variation of photoelectric current with following quantity. Now we are reading the variation of photoelectric current. Clear? Means on what parameters, what quantities these photoelectric current increases or decreases. Clear? Okay, first student, effect of intensity of the incident radiation. What is intensity? Try to understand this word intensity. Intensity means intensity is called number of radiations per unit area per unit time. Okay, area into time. So if you increase the number of radiations, if you increase the number of radiations, okay, like there is a window, here it is a window, and this is a cathode. Clear? Now you increase the area of the window. Okay, as you increase the area of the window, or you can say, if you have increased the intensity, means number of radiation. Previously there was only one radiation. Suppose there is only one radiation. Clear? Now there are five radiations. Okay, one, two, three, four, four radiations. Fine. The work function of this metallic surface equals to 3 electron volt, and you have emitted the radiation with 4 electron volt, 5 electron volt, 6 electron volt, 7 electron volt. Four radiations are there. Clear or not? Now tell me, student, how many electrons will be fetched out? One, two, three, or 4? How many electrons will be fetched out? See, is this radiation the first one of 4 electron volt is affordable to fetch out the electron? Yes, because it is 3 electron volt and here it is taking the energy of 4 electron volt. So it is quite comfortable to fetch out the electron. So there is 1 electron will get out. Yes or no? Again, 5 electron volt is higher than 3 electron volt. So this will be carried a electronic emission. This is also 6 electron volt can also release an electron. And here is also release of electron. Means 4 electron will be there. Yes or no? So what happened? You have increased the intensity means number of radiation. Okay. So previously there is one radiation of sufficient energy, so it has released one electron. If there are five radiations of sufficient energy, okay, then they will release five electrons. Clear or not? Means so if the number of electron increases, means the number of current also increases. Yes or no? So means the value of photoelectric current is directly proportional to the intensity of radiation. Yes or no? Clear or not? As number of electrons that phased out is proportional to intensity. Okay? And if number of electron increases, then intensity increases. है ना? Then current is also increases. Clear or not? So multiple relationships are there. So see here, by varying the intensity of incident radiations, keeping the frequency constant. Yes, must know frequency has an important role. Frequency should be of that amount that is greater than threshold frequency. Only then electronic emission will be there. So keeping the frequency constant, it is found that the photoelectric current varies linearly with the intensity of incident radiation. Means as you increase the intensity, number of electrons will be increases. So the photoelectric current also increases. Clear or not? For zero frequency, there is electron. If you increase the frequency linearly, then number of electrons also increases. So the current also increases. Clear or no? So intensity versus current. So current is directly proportional to intensity. Clear? Okay. So mark there in your NCRT book. Right there. Current is proportional to intensity. This is first observation. Okay. What current? Photoelectric current is proportional to intensity. Photoelectric current is proportional to intensity. Okay. Hmm. So what happened? As you increase the intensity, means number of radiation here increases. By increasing the intensity of light, number of radiations also increases. By increasing the number of radiation, the fetched electrons, photoelectrons are also increases. So number of photoelectron, one line is also maybe there. Also the number of photoelectrons emitted per second directly proportional to the intensity. Obviously, because if you increase the intensity, number of photoelectrons emitted per second also increases. Clear? Of the incident radiation. As the number of electrons increases, photoelectric current will be increases because current, the formula for current Q equals to I equals to Q upon T. I equals to Q upon T. Clear? And Q is what? Ne. N means number of electrons, E means charge of electron upon T. So as the number of electrons increases, charge will be increases. So current will also increases. Clear or no? Okay. Done. Next, effect of potential of plate A with respect to plate C. Second observation, effect of potential of plate A with respect to plate C. This is our, we having a tube, vacuum tube. This is our cathode. Okay. This is the cathode, radiating cathode, and this is collecting anode. Okay. This having negative potential like -3, some negative potential like -3, and this having positive potential like first it is 0. Clear? Now see, you have incidented radiation by window and there is a fetching of electron. Clear? So if this electron is negative charge, is this electron having negative charge? Clear? Then by its own energy, it can, by its energy, it can going towards anode and will constitute a some amount of current. Clear or no? Okay, current, if the current electron is going here, so current will, sorry, the current will be flowing this direction. Okay. Now see, now first previously it is on 0 volt. Now you have increased your trigger, like controller of your fan, your voltage raised by 1 volt. Mhm. Okay. Now it is on positive one. Now electrons, again the electron emitted, feeling a slow attraction towards this plate. Yes or no? So it is moving somehow fast comparison to the previous one. Yes or no? After then, continuously you increasing the voltage plus 1, plus 2, plus 3, plus 4. The attraction of electron will be increases and they move rapidly. Yes or no? But can this anode, can this anode potential make the number of electron increases? Can this anode is helpful to getting electron out of the surface from the cathode? Yes or no? Yes or no? I ask the question, does the potential of the anode, okay, if you increased it so much times, does it help to fetching the electron out of the surface or no? No, very good. Because fetching of electron is a duty of radiation. It is not a duty of anode. Once the electron getting out, it can give its motion, rapid motion. Yes or no? But this cannot fetch the electron out of the surface. Okay, who can fetch the electron? Only radiation. Clear or not? Like there is a water supply from corporation to your home. Clear? Either by using a pump, water pump, you can increase your supply to some extent. Okay. But if they release 10 gallon water per hour, so can you avail a water of 50 gallon per hour at your home? Only there is a supply of 10 gallon. Okay. Then how can you get a 50 gallon? No. Okay. By using a pump, what you can do, you can interrupt the supply to your neighbors. Okay, the water that is coming towards your neighbor family, okay, that is rush towards you and he will get a less pressure. Okay, but you cannot get a 50 gallon per hour. Okay, so likewise you cannot fetch out more electrons. Clear? Okay, so you can give a somehow some rapidness to the electrons, but you cannot take more electrons out of the cathode. Clear? So see the graph here. Like by increasing a potential, there is a some very little hike in current. Yes, by rapidness. You see, previously the your potential is zero here. What is your potential? Zero. Okay. Your current is here for zero potential. Clear? Current is here. Now, if you increase your potential, bit of current increases. You see the increase of current. You got it? So there is an increase of current by increasing the potential, your potential. Then after, when saturation comes, number of electrons are all the electrons are gathered. Now doesn't matter how in what amount you increase your potential, as there is no supply of the electrons, so you will have your constant current. Clear or not clear? Okay. Again, for high intensity, first there is a radiation of less intensity, I1. Okay. Now, high intensity, you increase the intensity. I1 is the less intensity. I1 is less. Then you increase I2. So as you increase the intensity means number of electrons, number of radiations increased. Yes or no? So number of radiations increase means fetching electrons also increased. So the current will be increased. Yes or no? Now, by applying positive potential, up to some extent, your current will be increases, but after then there will be a saturation. Clear? Yes. Then after again, by increasing intensity, you have incidented some more photons, then electrons number also increases. And by uh, apply a positive potential up to higher value, you have get a minimal height or hike of current. Then after again it is become saturated. Clear or not? Now see. So till now you have applied your positive potential for the electrons. Clear? This is your emitting cathode having on negative potential. So the electrons are released from here. And this side, there is a positive potential. Clear? Now you wish to apply here negative potential, -1. Okay? You connected this one from the negative end. Clear? You're reducing the potential, positive potential. Now you connected to the -1. Then what will happen? By connecting it with a negative potential, the electron will feel a repulsion. Yes or no? Hey, don't touch me. I'm negative. You also negative. Just repel away. Yes or no? So this electron feel very much trouble to reach this you reach this terminal. Okay? And the amount of current will be slow down. Means current become less. Yes or no? Continuously you're decreasing the potential. First there is -1, then it is -2, then it's -3. At some point like -15 volt, there is so much repulsion, so the electron cannot even touch this negative terminal. Clear or no? So this is called, at this position current becomes zero. Current becomes zero because no electron have a courage to touch this terminal. Okay, yes or no? So at this situation, current becomes what? Zero. Clear or not? Okay, so increase your potential in the negative situation. You see, if you have here, you have increase your potential +1, +2, +3, +4. Now increase your potential in negative side. -1, current is decrease. Yes or no? You see, there is a decrement in current here, decrease. Here it is current decrease, current. -2, more decrement in current. And -5 or -6, there are absolutely zero current. Yes or no? At this potential where the current becomes zero, this potential is called, this negative potential is called stopping potential. Okay, stopping potential. Clear or not? Yes. So here the kinetic energy of whole the electrons made zero. Okay. Yes, there is absolutely no motion of these electrons. So kinetic energy becomes zero. Clear or no? So let us suppose if you have applied the potential of V naught, negative potential of V naught, and there is a charge E, then the what is the energy? Electrostatic energy. U equals to, by the formula U equals to QV, you have energy EV naught. Q means charge on electron, V means stopping potential EV naught. Yes or no? And this energy is used to prohibitate the energy of this rapid electron, means to cancel the energy of its kinetic energy, half mv square. So make a relation here, ev naught becomes half mv square. Clear? This is kinetic energy of the free electron, and this energy is collapsed by this electrostatic repulsive energy, ev naught. Okay, so half mv square is equals to ev naught. Clear? Okay. Like one day you came to school in a very energetic way. Okay, you just getting out of the school bus door. Okay, when very dancing, swinging mood, singing mood, you just entered your classroom. Okay, with a high kinetic energy. Okay, and your teacher ask you a very difficult problem of physics, and you getting a 0 marks. Then what will happen? Your total energy collapsed. Yes or no? By this electrostatic energy EV naught. So this half mv square collapsed by electrostatic potential energy ev naught of repulsion. Clear? Okay. Same feeling here. So ev naught equals to half mv square. Written the formula? Yes. Okay, student. So reading the effect of potential of a plate A with respect to plate C. So we have the two plate. One is emitter plate C, and one is the emitter is sorry, collector plate A, that is anode. It is found that photoelectric current increases gradually with the increase of positive potential plate of A. Yes, there is a gradual increment. Yes, I am again using the green pen. So after zero voltage, if you apply the anode potential, if you raise the anode potential, there is a gradual increment in the current. Okay. At one stage, for certain positive potential of plate A, the photoelectric current becomes maximum or saturated. But after some point, the current becomes saturated because no new photoelectron will be released. Right? After this, we increase the positive potential of a plate A. There will be no increase in the photoelectric current, obviously, because no photoelectron are supplied there extra. So the maximum value of current is called saturation current. Here the current is called saturation current. Okay. The student must remember, here I am showing the three graphs with different intensity. This is not a single graph. These are the three graphs for three intensities. Clear? Where intensity I3 is maximum. So you will have more current than I2 than I1. So this maximum value of current is called saturation current. This saturation current corresponds to the state when all the photoelectrons emitted from the C reach at plate A. Yes. Saturation current obtained when all the electrons, okay, all the electrons emitted from C reach to the anode. Highest current. Now apply a negative potential. Now come to the back side. Now continuously reduce your potential. Okay. Again go backward, backward, backward. Okay. Now applied a negative potential plate A with respect to C. We will note that the photoelectric current decreases. Yes, by applying a negative potential as repulsion increases. So there is a decrement in the electric current. You see the current continuously decreases. Okay, decreases because the photoelectron emitted from the C are repelled by only energetic photoelectrons are reaching to the plate A. Yes, they are repelled by the anode A. Okay, and continuously there is a increasing repulsion for the electrons. So the number of electrons striking to the terminal A continuously decreasing. By increasing the negative potential of the plate, the photoelectric current decreases rapidly and becomes zero at a certain value of the negative potential V naught on plate A. This maximum negative potential V naught given to the plate A with respect to the plate C at which the photoelectric current becomes zero is called a stopping potential or cutoff potential. Clear? This is cutoff potential. Now, in this situation, your kinetic energy, maximum kinetic energy is, you can say, collapsed by the electrostatic potential energy EV naught. So here K max, the kinetic energy of the electrons, is equals to EV naught. Okay. And what is the formula for kinetic energy? Half mv square. So make the formula EV naught equals to half mv square. Okay. E is the charge on electron, m is the mass of electron, v is the maximum velocity of the emitted photoelectron. Clear? Yes. The value of stopping potential is independent on the intensity. You see, there are the three different intensities. Okay. This is high radiation, then after then this, then. But all the three radiations having the same stopping potential. This having the same stopping potential V naught, this having the same stopping potential V naught, this having the same stopping potential V naught, means stopping potential is independent on independent on intensity. Yes, make a point there in your book. Stopping potential is independent on intensity. Yes, it does not depend on intensity. Okay. Stopping potential is independent on the intensity. of the incident radiation. It means the maximum kinetic energy of the photoelectrons depend on the radiation sources and nature of material of plate of C, but is independent on the intensity of the incident radiation. Clear? It means the maximum kinetic energy of the emitted photoelectron depends on the radiation source and nature of the material of plate C, but it is independent of the intensity of incident radiation. Student, here up to here, this is important. This after then is not useful. Okay, means stopping potential only here. Stopping potential doesn't depend on incident radiation. Clear? Hmm. Next, now student, check one more thing, giving some elaboration to the same topic. We have seen that EV naught, where V naught is the stopping potential of cutoff potential. This this EV naught, okay, this EV naught eradicate whole half mv square. Okay, means collapses the kinetic energy half mv square. Okay, now come to the point. We know that energy given, radiation given, E radiation given to any photoelectron. Yes, this is photoelectron. This is the energy of the radiation given. Expenses in two part. First, to give its work function, that is a constant. Okay, so that is a constant work function. Then after half mv square kinetic energy. Clear? If the remaining energy will be there, means there will be some kinetic energy that will be present in the form of kinetic energy. Clear? What is E? E is equals to h nu. Equals to h nu equals to phi naught plus half mv square. Phi naught plus half mv square. So half mv square, you check, half mv square equals to half mv square equals to h nu minus phi naught. Clear or not? And this half mv square equal to ev naught means ev naught equals to h nu minus phi naught. Clear or not? H nu minus phi naught. So by this relation, you can have idea, like if you have increased your incident frequency, if you have increased your incident frequency, then you have to apply more stopping potential. Clear or not? Because this having a fixed value, phi not having a fixed value, like see, phi not having a fixed value, consider it is like 3 electron volt, or sorry, 10 electron volts. Clear? Now consider this is equals to 10 electron volt, and you having h nu of different electron volt. See, h nu of different electron volt. First, I given a value of h nu equals to 20. Okay, so 20 minus 10 equals to 10. 10 electron volt. Clear ki not clear? Now you have given 30, then it becomes 30 minus 10 electron volt equals to 20 electron volt. Okay. When you have given 40, so it will have a value of 30 electron volt. Clear or not? So you see, when you increased this incident energy, incident frequency, more incident frequency will constitute more energy, and more energy means more stopping potential. Yes or no? So by increasing the incident frequency high, you will have a more stopping potential. Got it? Okay. So more stopping potential is there. So um, what does it mean? It means that by increasing incident radiation frequency, stopping potential also increases. Clear or no? Yes. So by increasing incident frequency, photon, okay, stopping potential also increases. Clear? Hmm. So V naught is proportional to V. Done? So student, from this situation, we have got an idea. Maximum the energy of radiation. Maximum the energy of incident radiation means maximum its frequency, and it will have maximum frequency. You have to apply more stopping potential. Clear? Means by increasing frequency, you have to also increase the stopping potential. Clear? Okay, so our next topic is on the same uh, heading, effect of frequency on incident radiation. Effect of frequency of the incident radiation. Yes. Effect of frequency of the incident radiation. When we take a radiation of different frequencies but of same intensity, then the value of stopping potential is different from the radiation of different frequency. Okay, so you have three radiations. Suppose you have three radiations. First radiation frequency nu 1, second radiation frequency nu 2, and third radiation frequency nu 3. Obviously, greater will be the radiation, greater will be the energy. Means if nu 1 is lesser than nu 2 is lesser than nu 3, means third radiation having highest energy, then second radiation having highest energy, then after first having the least energy. Clear or no? And you see in the last situation, greater the energy, greater you have to apply the stopping potential. Means for third radiation, you have to stopping potential is maximum, V naught 3 is maximum. Then after V naught 2, then it is less V naught 1. Clear or no? Okay. The value of the stopping potential is more negative for a radiation of incidence, higher incidence frequency. Yes, check. For the higher the frequency, you having a higher stopping potential. Lesser the frequency, you having a lesser stopping potential. Clear or no? For radiation of higher incident frequency, the value of saturation current depends on the intensity of incident radiation, but is independent of the frequency of incident radiation. Obviously, you see, you have the three radiations. Check here. You having the three radiations. Nu 1, nu 2, nu 3. So three radiation nu 1, nu 2, nu 3 corresponds to three energies E1, E2, E3. Clear? Yes. The nu 3 having the highest energy, nu 2 having the some less amount of energy, and nu 1 having some less amount of energy. Clear or no? Okay. The higher energy radiation will reach towards the anode more quickly, so it having a higher amount of current. After then it will getting a saturation current. Nu 2 having less energy, so it will having a some less amount of current compared to the nu 3, and nu 1 having more less energy, so it will having a weakest amount of current. Clear or not? Okay, because energy is maximum for the third one, then it is second one, then it is first one. Now, for stopping potential, you check here. Nu 3 having the highest frequency, so it will be have a greater V naught 3. So check, for making the photoelectric current zero, you have to apply a stopping potential of V naught 3, that is greatest among V naught 3, V naught 2, V naught 1. So now for V naught, it is on second level and it is for first level. Clear or not clear? Means greater the incident frequency, greater will be the stopping potential. Clear? Done. Okay, students. So make this derivation. This is important for your understanding. EV not equals to half mv square. Clear? This is one of the scene we have seen by stopping potential equals to kinetic energy. Stopping potential is used to suppress this kinetic energy. Now, second, by the photoelectric equation, total energy E is used in two parts. The total energy given to the radiation to the photoelectron E is used as two forms. First, some amount of energy is used to fetch out the electron, that is called phi naught work function. Clear? But that after then, like you have given 10 electron volt, 7 electron volt is used as work function. Now 3 electron volt energy behave as a kinetic energy. So this becomes as a kinetic energy. half mv square. Clear? What is E? E equals to h nu. Okay. H nu equals to phi naught plus half mv square. Clear? So made half mv square equals to h nu minus phi naught. Right? Half mv square may be written as h nu minus phi naught. Okay. Now in the place of half mv square, can you write ev naught? Exactly. So half mv square becomes ev naught equals to h nu minus phi naught. Clear? Because phi naught is constant. So by increasing the incident radiation frequency, if you increase this incident radiation frequency, then V naught also should increase. Yes or no? Also have to increase. So V naught also need to increase. Clear or no? Clear or not? So V naught also need to increase. Yes, V naught also need to increase by increasing the incident radiation frequency. Yes, you can also write like this. V naught equals to h nu upon E minus phi naught upon E. Clear? This is the relation between a stopping potential and incident radiation frequency. Yes. What is this? Relation between a stopping potential, your cutoff potential, a stopping potential, and what? Incidence frequency. Incident frequency. Clear, students? Yes. Right. Okay. Next topic is effect of frequency on stopping potential. Just now we have seen this effect of frequency on stopping potential. As you increase the frequency, stopping potential also increases. Yes or no? So stopping potential is directly proportional to the incident frequency. By increasing incident frequency, your stopping potential also increases. Clear? So here we have the situation. This is incident frequency. This is the scale for stopping potential, potential V. Now you know stopping potential is negative. So here you have two frequencies, first frequency and second frequency. Check there. This is first frequency and this is second frequency. Clear or not clear? First frequency, first radiation, you have a frequency of nu A. For second frequency, or you can take nu 1, better you can take nu 1. And second frequency, nu 2. Clearly, you check because nu 2 is more forward. So nu 2 second frequency is greater than nu 1. Okay? Yes. So nu 1, here it is nu 2. The two frequencies are there. Here the nu 1 and nu 2 are the two frequencies. Okay? And we have to observe the frequency versus stopping potential. Means two frequencies, different frequencies are there. Now check for a frequency nu 1, there is a less stopping potential. You see here it is a less stopping potential by V naught 1. Clear? And for nu 2, there is more negative stopping potential, that is V naught 2. Clear? So greater the stopping potential, greater the frequency, you will have greater stopping potential. Clear? See, effect of frequency on the stopping potential. For a given photosensitive material, the stopping potential varies linearly, means directly proportional with the frequency of incident radiation. Means if you increase the frequency of incident radiation, your stopping potential also increases. For every photosensitive material, there is a certain minimum cutoff frequency called V naught threshold frequency, for which the stopping potential is zero. For which stopping potential is zero. So check here. Here the two metals. First metal having this threshold frequency. Clear beta? And second metal having this one threshold frequency. So you see, if you increasing the incident frequency, you see this is the incident frequency increasing here. Okay. So by increasing the incident frequency, stopping potential also increases. You check the stopping potential also increases. Clear or not? See here, the stopping potential frequency increased here, so it will also increased. Now it is up to here, also potential increase. Frequency is up to here, potential increase. Frequency is up to here, potential increase. Clear or not? So stopping potential is directly proportional to frequency. Clear? Any problem? Okay, so this is the relation stopping potential versus frequency. Clear? We have the derivation V naught equals to h nu upon E. V naught equals to h nu upon E plus uh, plus minus phi naught upon E. So I can write here it is equals to minus phi naught upon E. Okay? So by mathematics, if you consider it with the equation y equal to mx plus c, so this behave as a intercept. So phi naught upon E is an intercept. Okay. So for first radiation, you have a intercept of phi naught 1, negative of phi naught 1 upon E. And for a second radiation, you have an intercept of phi naught E upon phi naught 2 upon E. Yes. The intercept on the potential axis equals to phi naught upon E. Phi naught value of phi naught equals to h nu naught. We know phi naught is the work function. This is equals to h nu naught. So, yes, done. Clear. Only one last thing, students. There is no time lag between the incidence radiation and emission of photoelectron. Means there is a spontaneous emission. As the photoelectron strikes on the surface, tentatively, only that moment your electron will be released. So there is a time lag of 10 to the power minus second, near about 1 nanosecond. Clear? Yes. So there is no any time lag. There the time lag between the incident radiation and the emission of photoelectron is less than 10 to the power minus 9 second. This is called spontaneous. Clear, student? So this is complete observation related to the frequency and stopping potential. Done.